Okay, so let's come back to where we were. So we have everything ready for both models, but now we have to prepare things for OAP. So first, we will prepare the non-couple, so which is a name list, what's happening, what variables will be exchanged, etc. So first, we will need to copy this name list from the Oasis in directory. And as I said a bit earlier, we have several non-couple based things ready. And so for today, we want to couple with ocean and wave. So I will use a non-couple.base.ow for ocean wave. And I will copy there as non-couple. So now I have the non-couple here. I will open it. As the description that I did this morning, you can see that here I've decided to couple 6 fields. So significant wave height, mean period, mean direction, sea level from CROCO, and U and V component of the velocity from CROCO. So then I'm using 2 models. So and the name of the executables that I have changed a bit earlier are WaveWatch and CROCO X. Then I have to prescribe the runtime. So here I have to change something. And you remember it's 30 days in seconds, so it's like 2,592,30. Then I have the debug level that I will keep to 1. And then here, if I go down, you can see there are a lot of comments explaining the variables that can be exchanged. But if I go further down, here I'm arriving to the part where I have the CROCO towards WaveWatch fields to exchange. So here, first the sea surface height, that is my CROCO SSH, WaveWatch 3 _ SSH. And then I have to prescribe, so the variable names are already set up, but then I have to prescribe the coupling time step. So it's what is into brackets named CPLDT, as you can see. And CPLDT, as you can see, for each field, SSH, the ocean velocity, etc., I can prescribe a different coupling frequency if I want. In fact, I don't want, I will set up the same coupling frequency for everywhere. So either you change it in every places, or you use a command to change it at all places at the same time. That's what I will do. So we change the CPLDT. I'm a VI friend, so wow. And I will say that I want 6 hours, so 21,600 seconds. Okay, and I will change that everywhere in my file. So if you prefer to use another editor, you can do that. Otherwise, in VI, when you want a command, you use double points, and then person says everywhere, S for said, and then you first what you want to change, then the second is what you want to change, and the G for global. So then I do that, and now I have 21,600 everywhere. That's what I want. Okay, so for the coupling frequency, we are fine. Then I have to put settings on the grids. You remember, first I have to prescribe the sending grid. So here's the ocean grid, and then the wave grid. Okay. As I said, I've used the same grid, so it will be the same number for me. And I will also change all this automatically everywhere, because I have to do it for each variable. So for the 3 ocean, for the ocean first, it was 41, 42. Okay, so I change it everywhere. So you can check that here for my first variable, I have now my grid set up for these 3 variables, and also for the WaveWatch to CROCO variables, I've set up the grid for CROCO. Okay, now if I change also the grid for wave watch that I want also, which is the same, I can change all at once. Okay, so now you can see that for each variable that I want to exchange, I've set up the grid numbers. So the number pointing in the X and Y direction that are currently the same. You can see that I already have the grid names for Oasis that are set up. So I'm exchanging from the raw grid of CROCO where I am SSH, but I'm exchanging the U velocity from the U grid because it's not on the same grid, if you remember, and the V velocity is on the ocean V grid. So I can do that, and Oasis will perform interpolation from the U grid towards WaveWatch grid, from the U grid, V grid, and T grid. Okay, so you will have 3 different remap files for the different grids. And then I have to change this lag thing, if you remember well. So as you can see, for the variables that are from CROCO to WaveWatch, here should be the ocean DT. If you remember well, the ocean DT was 3,600 seconds. So I changed it everywhere. So for the ocean towards the wave variables, everything is set up now. We have a regional grid. We have an average in time transformation. We have a distributed weight interpolation. So for these 3 variables. And for WaveWatch to CROCO, almost everything is set up except the lag. It is now the wave model lag, so the wave DT. So I have to change that also. So I'm changing wave DT. And it's also 1 hour, so it's the same number there. So now my 3 variables that I will exchange from WaveWatch to CROCO are set up also. And this is it. I can save. So now I'm moving to ADM. So now I have CROCO setup, WaveWatch setup, Oasis names, but as you can see, I'm still missing Oasis restart files. So I have to prepare them. So we have written 2 little scripts to help you do that. You can do it another way if you want, but we have 2 little bash scripts that with the LCO library are using CROCO grid or WaveWatch 3 previous files that we can have generated to build these conditions. So you can build the condition from a previous ocean only or wave only run, something like that. And we have 2 scripts, one that create restart from calm condition, let's say 0 all the time for all variables, or that can create restart from pre-existing output file that you could have from a first run that you have done before, for example. Okay, to start from an initial field that is a bit different. Honestly, it's not very of strong importance because it only constrains the first exchange of variables from Oasis to the models, and then at the first time step of coupling, so after 6 hours, it will exchange the true variables from the models. So it's not very important, just don't look at the first 6 hours if you put everything to 0 at the beginning. So today we will use the create restart, Oasis restart from calm condition. This script can be found in the script toolbox Oasis scripts. So I will copy this file from there. So create Oasis restart files from calm conditions there. So now I have this file. If I don't know how to use it, I can have a look at the file. But I can just try to launch it and it will say to me error because I'm missing a lot of arguments, and it says to you what it needs as input. So the first input should be a file from the model that contains the mask. That's what we use the former WaveWatch 3 output, for example, to have master, which is the WaveWatch 3 mask. And we can use the CROCO grid where we have the CROCO mask for CROCO. Then you have to give a name, so it should be consistent with the non-couple. You have to say what type of model it is. and you have to list the variables that you want to generate in this restart file. Okay? So basically, I will first link for WaveWatch the files from the previous one that is in WaveWatch 3 files actually, that I need there. And then I use my script. So first I say, okay, I want to use this WaveWatch 3 file. Then I say, I want my restart file to name wave.nc. It's a WaveWatch 3 input. And the variables that I want are the mean period. Mean period. If I mistake there, it won't work. Then I want these two underscores, the quotient HF, significant wave height, and I want the direction that is named for Oasis WaveWatch 3 data. And then I press enter. So it's saying it's extract master variable from the WaveWatch file and just put 0 everywhere we have ocean. Very easy. And so now you have this wave file here. Let's do incident minus h on this wave file. You can see that I indeed have my 3 variables that I want to couple available on the good grid in this file. So this is for Oasis to be able to restart. I do the same for the ocean variables. So I'm saying I'm using CROCO grid. I want to build the file that is named CROCO2024, sorry. My input model is CROCO, and the variables that I want are the SSH, the northward ocean velocity, and the eastward ocean velocity. Okay, so I build that. So basically, there's really mask row then, and replace everything there by 0. And now I also have the oc.nc file with my 3 variables, okay, on the grid. Okay? Okay, then. Seems that now I'm ready. So to start to be able to launch a run, you need to have all these steps done. So prepare this file, set up the name list for CROCO, prepare all these files for WaveWatch, set up the name list for Oasis, and prepare the file for Oasis. We are ready to run now. Great. So basically,
sorry.
Yeah.
So all variables on raw points. So when CROCO exchanges velocities,
there are not actually there are new on V, but here, as you can see, it's just that I've replaced the mask because we are using, as you can see, the inner. So it's 4142. It's the same that it's the inner CROCO domain. That and the number of these points is the same for the UV grid and the raw grid because we don't have the same ghost points. You know. If you look at the output, you will have more. I will show you that a bit later. 4142 is what you have in param.h, which is really the inner grid.
Okay.
But when you will look at output, so CROCO history or AVG file, you will see that I will have for raw grid 43 and 44 points, and for UV, 1 less in the UV direction.
Okay.
Okay. So basically, we are just coupling in the inner part of the domain that is really the computing part of the code without the ghost point that are elsewhere.
Okay.
It's the way it is coded for the exchange in CROCO.
Okay.
Okay. So yeah, for CROCO, remember that if you don't know what are the number of points in X and Y, check in param.h on your configuration. These are the number of points that you want to set up. The same in param.h.
Okay.
So to launch the simulation, we could use srun, but as you have seen earlier, if I do that on the master node, it won't work. So I will edit first the job.slurm that I prepared. So I will change that. I was saying I want to run on 4 processors, 2 for CROCO and 2 for WaveWatch. For CROCO, I haven't the choice because I compiled CROCO with 2 processors. So if I put another number, it won't work. But for WaveWatch, I can change. I can decide to run WaveWatch only on 1 or on 4 or whatever you want. I decided 2, but you can choose. So here, I first have to give the number of CPU tasks to my Slurm software. So I pick 4 processors there. I will change a bit the time because I'm not sure that 5 minutes, maybe 10 minutes will be the deal. And here, I will say to Slurm how to launch both executables together. So if I do that directly in the master node and I'm alone and it's working, I can do srun minus n2 WaveWatch double points minus n2 CROCO. But if I do that in a batch script, it won't work. So I have to use another type of command that is named for Slurm, depending on each machine. An option that is named multiprog. So it says to Slurm, okay, we'll give you several executables to run. And the way I will load the CPUs with these different executables will be given in a text file that I will give to you also. So I named it app.conf, but whatever you can name it, my CPUs if you want. And so then I have to prepare this app.conf file. So it's configured for the Slurm. So I have to create it. So it's an empty file now, and I will say, okay, I will allocate the CPU 0 and 1 to CROCO. I think I put that just in case it's not executable. And I will use CPU number 2 and 3 for WaveWatch. Okay, this is saying that to Slurm. So I will save this file, and now I can run my job.slurm. And hopefully, let's finger crossed, it will run. It's running at least.
But you didn't build Oasis.
No, Oasis is a library. It's not an executable. So Oasis is a library. So when I compile CROCO and WaveWatch, I just linked the executable to the library. So it's embedded in the executable. It has the path to the library. And when you call an Oasis function, you just call the library.
That's a bit just
yeah. So now it's probably still running, but you can see that already I have several, you remember I was there. And all these are new files that have been generated. It was easier than generating the previous one. So you can see that I have the nout file, which is, I said, one of the logs from Oasis. I have also these 3 NetCDF files for the grids, areas, and maps that were generated also by the code putting the grids for Oasis into. I have also the debug files that have been generated, so debug not root and debug root for the 2 models. I have the remap file, so the weight for the grid interpolation. And as I said, I have 3 ocean grids and 1 wave grid. So I have the 4 interpolation files. And finally, I have my model outputs, so I can see the CROCO history. I can see the outgrid.WaveWatch3, which is the binary output from WaveWatch. And maybe still running. And you can see that I have the log from WaveWatch. This is a text file. If I want, I can check where it is at the moment. So basically, it is there. The date. So WaveWatch3 log file say, okay, we have started 1st of January 2005. It has run now for 11 days. Okay. Yeah, full report. And yeah, in WaveWatch, maybe it's interesting for you to know that. So this table, So it says where it is in the days, and it also says where what fields and what exchange with the input or output it has done. So you have input, so this is boundary. No, I don't have boundary. This is wind. Yes, I have wind. This is level, and here it says update. So it has update the level from CROCO. Here it says current, and this is ice, another for ice, and I don't remember. And for the output, it says, okay, I guess this is a grid output, so I decided, you remember, to have my main field every 6 hours. So I have a post every 6 hours. So it has written things every 6 hours. And it's also saying here, the C is for coupling, that every hour it has transmitted something to the coupler. So we have post every hour. And the other output are point output, but I didn't choose that. Track output, restart. I will have a cross at restart at the end. Eventually, this may be for boundary, I don't know. VMF, I'm not sure.
I don't understand well the difference between update and exchange.
Honestly, I don't know. I think WaveWatch maybe, I don't know why it's named sometimes updates and sometimes it's a cross. No, maybe it's just different routines and it's for levels, it's always update, I guess. I don't know why. We can check maybe in the WaveWatch manual, but basically it's doing something. For CROCO, I don't have a log file here because I didn't request one. There is a CPP key that you can activate that says log file and put all the logs for CROCO in a file. Otherwise, the log for CROCO will be in the job output directly. So it's probably Slurm something. Yeah, here we have first called to Oasis initialization, and then you have the usual, if you're used to CROCO, output that it says, it's written the CROCO.in, so it starts saying a lot of things there. And once here we have start of the get initial, and then there are some additional instructions for coupling, saying what it will be coupled. And then here, yeah, we are starting getting bulk somewhere. Yeah, it's running.
I remember you remember the presentation from Uday, from Colombia? They were doing these short runs of the models to create an initial condition. They were not doing cold starts.
Yeah.
Short run, and then they will start the coupling mode. Exactly.
Generally, what we do, especially for ocean configuration, as the ocean is quite slow, except if you are starting from a reanalysis and you are in a similar resolution, but if you are not, you want your mesoscale to develop and your small scale features to develop at the resolution that you have, you should do a spin-up, and you could do the spin-up only in forced mode first. So for a few months, or depending on what you're looking at, maybe it will be a few years. So you do your ocean spin-up, and then from the end of the ocean spin-up, you can use the other script that is create or as a restart from previous file that we have, and say, okay, I want the condition like this for CROCO. And for the waves, you can also do a little spin-up, but for WaveWatch, generally, you use the spin-up of, depends on the size of your area, but even at the global scale, I do a spin-up of 15 days maximum.
Yeah, that's good.
So very easy to start. I'm just going to show you a bit more the output file from Oasis, because they are quite okay. My run is finished. So at least it's finished from the job. I can check if everything went well. So at the end of the WaveWatch 3, okay, since it went up to the end, this is a good thing. If I check for CROCO here, yeah, name done. Good thing too. Otherwise, if I blow up in CROCO, it says blow up there. Another issue that you can have if you haven't set up properly the time consistently between CROCO, WaveWatch 3, and Oasis, either Oasis will kill something at some point because it's not consistent, or one of the models, but also sometimes it's like seems like running indefinitely but doing nothing because the compiler is just waiting for some variables that never comes and it's waiting until your job will finish and will be killed by the machine. Okay, so this is something that you should check if each of your models really finish properly or not. Okay, and so now just to give you a rapid look on what we have in the output and log files, so let's check out and with a lot of zero and out with a lot of zero. So basically here it's giving things about coupled variables, so you can check there when you have an issue. Okay, are there this field that I want to exchange? Is it a good grid? Or is everything prescribed correctly? So it's a really typical Oasis output that says for you field number 3 that, etc. Okay. And basically, when it starts running, because you have some calls from Oasis that are saying what it is doing at the moment. Okay. Then basically, when you have an error, check all these log files, go to the end, because generally the error is written at the end. You have also the debug root file that are quite useful. So it's the first one is for the first executable that we have. So you can check there. There are some also Oasis calls. So it says Oasis get local codificators, definition of partition, writing grids, finding grids, etc. It says a lot of things. And then it starts working, defining variables, etc. And at the end, Oasis terminates, so okay, it's ending properly. And as you can see, here it's for the CROCO executable. And you have the same for the debug roots 2 for the other executable. So where you have also a lot of information. Okay? So basically, if you have an issue, go at the end of this file and probably we find the error. Here, no error, successful, and we are happy. And you can also have a look at your classical output file. So for CROCO, you have restart history and average file. And for WaveWatch, at the moment, we have one restart and one grid, so typically bulk wave variables, but it's in binary mode. So if I want to look at them in netcdf, I can use the unf in name list. So I will edit it so that I can. So here in the unf, I also have to choose a date where I can extract. This is an interesting thing about WaveWatch. For example, if you run a simulation, but in the end you want output or look at the output only for the last month, you can just do the post-processing for the last month. It's working. But basically, I want everything, so I say that from the beginning, and I want things every 6 hours. If I ask every 1 hour, it won't be able to give me because I decided at the beginning in the shell that I will have output only every 6 hours. And here I can also choose to put out only a few variables and not the total amount of variables if I want. And here there are some numbers to say, okay, in which format I want to have my output name and stuff like that. Everything is detailed in the WaveWatch manual for that. So yeah, let's run that. I try it like that, but I will use a job. Which it should not work otherwise. So one. And here I've summarized all what is output, but I just showed you that now. And something to remember is also that the restart file for Oasis that we have prepared, you remember it was only zeros that I've put at the beginning, and now they have been overwritten at the end of the run. And so if I, for example, look at one of the variables, let's say SSH in ocean.mc, I don't have only zeros. I have numbers because it's the end of the simulation that have been stored into this file now, and I can restart from the 31st of January to do another simulation now. Okay?
The way over swing. The way over swing.
And it's done well. Okay. Yeah. Now we have the web of 3 outputs. Perfect. And so we can have a look at it. I'm not connecting into display mode, so I can't do anything, but I will just get out now and back in. Pretty sure the display otherwise won't work. So if I go back in my run directory, I was there. Now I can have a look.
You need to load the module.
Yeah, and if I source my own my path, it will know the modules.
Okay.
But you're right, I forgot that. And then I can open the Waywatch account that I just done. Oh, okay. Oh. Not happy at all.
Yeah, maybe you're loading a lot of modules when some there are.
Supposed to load the XCU.
I just loaded it on my path. Normal.
You load what the tunnel is going to load HDF5 to where XCU, let's see HDF5. You need HDF5.
Yeah, but in source on my path, it's done.
HDF5 too.
I show you. I guess yesterday actually. Yeah, it's done.
Oh, yeah.
I have an HG5 there.
No, just try XCU.
I
Or
can.
in library.
Yeah, I will. Let me just try again because yesterday I did it. It was working, but it's always when you do a demonstration, it's not working. That's the point. Okay. Let's go like this.
It needs. Yeah. Wants to load certain modules before you.
Actually, done automatic. I mean, let's do that. And then do that. I mean, it's really what they're telling you.
Yeah, I see one of those lines.
One of those. Okay.
So
Funny because yesterday it was working.
no, you need the EM, yeah, also.
Not happy.
No? But
Okay. If you manage slow, then maybe you can on the fly then. Super strange because this lady was working. Sure. Whatever. That's it.
okay, let me stop this.